Alright, so this is actually our final video for the year. This is the 6th root video, and what we're going to be talking about are solving right triangles and using the quadratic formula. So let's get started with right triangles. How to solve right triangles. So as you can see, over here on the right hand side, we have a right triangle. I've labeled the sides A, B, and C. And here, in this case, A, B, and C are the lengths of the sides. Right, so A, B, and C are length of the sides. And so here is the fact that you need to know in order to solve right triangles. The Pythagorean theorem says that whenever you have a right triangle, it's true that a squared plus b squared equals c squared. And another way of thinking about that is that the sum of the squares of the legs equals the square of the hypotenuse. Okay, so let's actually look at an example triangle. So here's an example triangle. And I'm going to tell you that one of the sides has length 5 and another side has length 12, and I'm not going to tell you the length of the hypotenuse. And if you use the Pythagorean theorem, right here, if you use that, you can identify that this is a leg, that's a leg, and that's a hypotenuse. And so 5 squared plus 12 squared has to equal c squared. Well, if we take that equation, 5 squared plus 12 squared equals c squared, then what we're going to get, well, 5 squared is 25, 12 squared is 144, that this has to equal c squared. 25 plus 144 is 169, and 169 is 13 times 13. Now, from this equation, we're going to use the square principle. And the square principle tells us that c has to equal plus or minus the square root of 169. And since 169 is 13 times 13, c has to equal plus or minus 13. Now, we only keep c equal to 13 since length is positive. Okay, so going back here, we can take this off and we can put 13 in its place. So let's try another right triangle. Suppose I told you the hypotenuse had length 5, this was 4, and this was unknown. First step, identify the legs and the hypotenuse. And remember, the hypotenuse is always the side across from the right angle. The legs touch the right angle, the hypotenuse is across from it. And so, remember, a squared plus b squared equals c squared. Here we have our a and we have our c. And so what we have is we have 4 squared plus b squared equals 5 squared, which is 16 plus b squared equals 25. To get b squared by itself, we're going to subtract 16 from both sides, which gives us that b squared is 9. And so b is plus or minus the square root of 9, and the square root of 9 is 3, and so we keep b equals 3. And so we have now our other side, and we have a 3, 4, 5 right triangle. So let's look at a more complicated example that's going to use some actual variables. So here I'm going to tell you you have a 3x x plus 1 right triangle. This is a leg, that's a leg, and that represents a hypotenuse, and so you have 3 squared plus x squared equals x plus 1 squared. Now, x plus 1 squared is x plus 1 times x plus 1, and we have to remember to FOIL, so we're going to multiply 4 things, and we'll get 9 plus x squared equals x squared plus 2x plus 1. Now, here you should know that you have a quadratic, and so you have to get everything to the same side, factor, and then solve for 0. And so we're going to get x squared to this side, 9 to this side, and on the left we'll have 0. My x squareds actually cancel. My 2x is left, and my 1 minus 9 gives me 2x minus 8. So now, when we solve for x, our quadratic has disappeared. We're stuck with linear, and so we can just add 8 to both sides, getting 2x equals 8, which is the same as x equals 4. And so now x equals 4, which means x plus 1 equals 5. And so you were able to solve this quadratic equation, which came from the equation for a right triangle. So let's solve one more right triangle. We have a hypotenuse of 3, a leg of 2, and a leg of size a. So we write a squared plus 2 squared equals 3 squared. So a squared plus 4 equals 9. Subtract 4 from both sides. So a squared equals 5. So when we have a squared equaling 5, we know that a has to equal plus or minus the square root of 5. So we only keep a equals the square root of 5. And so down here, we can replace this with the square root of 5. So it's also possible to have a leg length that isn't a nice number. Right here we have a leg length, which is a radical. So don't forget that that's totally possible. In fact, let's try one more. So here I have a fractional side. This triangle is obviously not drawn to scale, but we know here's a leg, and here's my hypotenuse. And so we know that 1/2 squared plus 1 squared has to equal c squared. When I square a half, right, that's a half times a half. 1 squared is 1. And a half times a half is a quarter. And when we try to add 1 to a quarter, we need to get it over 4, and so we get 5/4. This gives us the equation that c squared equals 5/4, and so c equals plus or minus the square root of 5 over 4. Now that can be simplified, right? We don't like keeping radicals around a fraction, and so if we get c equals the square root of 5/4, we can write it as the square root of 5 over the square root of 4, which is the square root of 5 over 2. And so our hypotenuse in the original triangle is radical 5 divided by 2. Alright, the next subject is the quadratic formula. So sometimes you need to solve quadratic equations which don't factor nicely. So suppose I have 3x squared minus 8x minus 5. Now the way you would normally try to factor this is by using the AC method. You would multiply 3 by negative 5 and get negative 15, and you would try to factor this into two numbers so that when you added them you got negative 8. And then you would group and you would factor. The problem is there's no two numbers which multiply to be negative 15 which add up to be negative 8, with those two numbers also being just integers. So we're going to need a more advanced method for factoring. So if you have ax squared plus bx plus c equals to 0, right? So if you start with this magic equation, then the quadratic factor tells us that x has to equal negative b plus or minus the square root of b squared minus 4ac, all divided by 2a. Right? And this is crucial. You're going to use that b everywhere you see a b, you're going to use the c everywhere you see a c, and you're going to use the a everywhere you see an a. So you're going to use the coefficients for x squared, x, and the constant everywhere. But this is going to let you get some answers, right? So let's rewrite 3x squared minus 8x minus 5 equal to 0. So my a is 3, my b is negative 8, and my c is negative 5. And so x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And so we can now plug in negative 8 plus or minus the square root of negative 8 squared minus 4 times 3 times negative 5 all over 2 times 3. Now, this is where we have to be very careful. Two negatives make a positive, so I'm left with 8 plus or minus the square root of negative 8 times negative 8, right, this right here, is 64. This negative and this negative are going to cancel and just become a plus. And 4 times 3 is 12, times 5 is 60, and 2 times 3 is 6. And so that means that we get 8 plus or minus the square root of 124 all over 6. And so these are the two answers to 3x squared minus 8x minus 5 equals 0. Now let's see what happens if it's something that we could have factored. For example, let's look at 4x squared minus 9 equals 0. Right? So here, A is 4, B, you notice there are no x's, and so B is 0, and C is -9. And so when we try to use the quadratic equation, x equals -b plus or minus the square root of b squared minus 4ac all over 2a, what we get is -0 plus or minus the square root of 0 squared minus 4 times a, which is 4, times c, which is -9, all over 2 times a, which is 4. These two negatives cancel, and so what we get is x equals the square root of 16 times 9 over 8, which is radical 16, radical 9 over 8. Oh, and I forgot my plus minus, which is 4 times 3 over 8. 4 goes into 8 twice, and so my answer is plus or minus 3/2. Now let's show that that makes sense. We had 4x squared minus 9 equals 0. Add 9 to both sides. We get 4x squared equals 9. Divide by 4. And so we get x squared equals 9/4. The square principle tells us that x equals plus or minus the square root of 9/4, which is plus or minus radical 9 over radical 4, which is plus or minus 3/2. The same answer. So you can see that the quadratic formula doesn't give you any problems with finding the answers. So let's try let's see what happens when there is no answer. Let's look at x squared plus 2x plus 3 equals 0. Here, a is 1, right? The number in front of x is 1. X squared is 1. B is 2. C is 3. And so what we get is x equals -b plus or minus the square root of b squared minus 4ac all over 2a, which is -2 plus or minus the square root of 2 squared minus 4 times 1 times 3 all over 2 times 1. So we get -2 plus or minus 2 squared is 4. 4 times 1 times 3 is 12 all over 2, which is -2 plus or minus the square root of -8 all over 2. Now, if you've been paying attention to the video so far, this should scream something to you. In particular, this should scream something to you. It should say, not possible. Is it ever okay to have a negative in the radical? The answer is no. And since it's not possible, the original, this, has no solution. We'll do one more. Here we get x squared minus 5x plus 6 equals 0. A is 1, B is -5, C is 6. And so we get x equals -5 plus or minus the square root of -5 squared minus 4 times 1 times 6 all over 2 times 1. So we get 5 plus or minus the square root of -5 squared is 25. 4 times 1 times 6 is 24 all over 2, which is 5 plus or minus the square root of 1 over 2. Now, here we can actually compute these answers. One is that x equals 5 plus 1 over 2, which is 6 over 2, which is 3. The other is x equals 5 minus 1 over 2, which is 4 over 2, which is 2. Let's go ahead and try these back in the original equation. 3 squared minus 5 times 3 plus 6 is 9 minus 15 plus 6. 9 plus 6 is 15, so this is in fact 0. 2 squared minus 5 times 2 plus 6 is 4 minus 10 plus 6, and 4 plus 6 is 10, take away 10 is 0. And so both of these answers work in my original equation. So here's an application of the square root that allows us to solve quadratic equations very quickly by using the quadratic formula instead of factoring. So that's really it. This is officially the end of chapter 14, which is about roots, and talks about the quadratic formula, which is from 15.3, which will be helpful for you on your exit test. So go ahead, do the homework, and I'll see you in class.